I'm not crazy about country living, and it's really not my desire. I'm not too crazy about country living, and it's really not my desire. But if I move back in the sticks, I ain't got to worry about being killed by no sniper's fire. Showing up.
Geology. 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 This is Daniel Minizini, your inquisitive geologist at Mini Geology. You can follow us at minigeology.com and you can write at minigeology@gmail.com. Welcome to Mini Geology radio show, where we put in touch our beloved discipline of geology with society at large. And today we're going to talk about the moon and many other planets in our solar system. But I would like to talk a lot about the moon, such a common object that we can all see almost contemporaneously every night. Since we humans, we populated this planet, and, you know, inspiring thoughts and poetry and music and novels and movies. And we'll talk about the moon and the solar system with Dr. David Kring. Dr. David Kring is a senior scientist at the Lunar and Planetary Institute, which is located in Houston and was founded in 1968. First dedicated only to the moon, and since 1977 also focused on the solar system. And research topics of the Lunar and Planetary Institute include the formation and evolution of the solar system, petrology and geochemistry of planetary materials and volatiles, volcanism, tectonism, and impact cratering. Is that right? Welcome to the show, David.
That was very well done. It's a very good brief summary of our institute.
And talking about your institute, David, I see that in the logo you have a motto that says inspiration and exploration since 1968.
Yes, we're quite proud of our history. We can trace our roots to the Apollo program. As you probably know, or hopefully your audience knows, it was President John F. Kennedy that launched America's initiative to send humans to the lunar surface and return them safely to Earth. Unfortunately, we lost President Kennedy, and his successor, Texas's President Johnson, realized that there should be an independent think tank or scientific institute that mirrored, paralleled, advised and helped NASA with the scientific endeavors associated with this type of lunar mission. And so he came to Houston March 1st, 1968, and he gave a speech that, in fact, you can hear on our website, where he articulated the need for this institute, and he asked the National Academies of Sciences to charter it, which was done. And initially, we worked with Rice University right here in Houston.
So I would like to go through those three different elements of your motto. First, inspiration. Tell us about the inspiration of the Lunar and Planetary Institute. What is the inspiration today for you?
Well, there's actually many levels to that inspiration. First and foremost, we are trying to, we are ourselves, the staff scientists, inspired. It is an amazing thing when you can go into the office every day knowing that by the end of the day you are going to learn something that somebody else has never learned before. And so on a daily basis, we go into the office excited, and we leave the office even more excited. And so there's this constant inspiring of ourselves through our work and of our colleagues up and down the hallways. But we're also a training facility. That is, we are designed to be one of the interfaces between the academic university community and NASA. And so we have a series of programs where we work with undergraduate students, we work with graduate students, we work with postdoctoral researchers to get them engaged in the type of science that NASA is interested in. And although I started with undergraduates in that list, we also have research programs that involve high school students. And some of those have been extraordinarily successful. We had one team of high school students who actually got a peer-reviewed professional paper published in the journal of Icarus. And it was so exciting that the flagship journal in this country, Science, wrote a feature article about those high school students. And so we tried to inspire the youth who will be our future scientists. And beyond that, we're constantly working to engage the public. We have a series of outreach activities. We have public events at the Lunar and Planetary Institute. We have public activities elsewhere throughout the city. And so at many different levels, we try to inspire the public, students, and, of course, ourselves.
What is the freedom of this inspiration? You can inspire as much as you have funding or as much as you are supported by the budget. Where is the limit of that inspiration? Also, depending on who is really supporting the Lunar and Planetary Institute.
Most of the funds that support the Institute come from NASA. We are a nonprofit institute, but we get most of our support from NASA to do NASA business. Most of the work that we do is proposed work. And this is oftentimes the way it works in American science. Scientists try to peer ahead, try to design experiments, try to design spacecraft missions, try to design sample analyses that can address important scientific questions on the science side, and we propose those investigations to NASA, and they either say yes or they say no. We also, in our role next to the NASA Johnson Space Center, also build a bridge between the scientific community and the exploration community. And by the exploration community, I mean largely the engineers and the astronauts that implement human spacecraft missions, whether it be in low Earth orbit with the International Space Station, or I'm hoping in the very near future with a revitalized lunar science and exploration program.
So the Lunar and Planetary Institute is funded by NASA. NASA is funded by the federal
government, Congress.
How heavy is the will and the power of politics, and how much they affect your ideas? How much freedom does it give you?
I wouldn't be able to comment on the political realities or the political constraints that govern NASA and the appropriation effort. That's not something that I deal with on a daily basis. What we deal with are scientific issues, the methods for exploring safely and efficiently, and we try to do that as cost efficiently and as timely a manner as we can. The pace at which we can make advances is obviously going to be governed by the amount of funds that we get, but that appropriations effort is something that is in other people's hands.
You highlight the American adjective when you were describing the method to do the research related to Lunar and the Planetary Institute. Why is it different from other countries, or which is the next country closest to what we do here in the United States?
Well, yeah, each country has its own architecture for supporting its scientific endeavors. In the United States, most of our work on the academic or the university side is proposal driven. That is, scientists and students propose concepts or investigations to the federal government, and they either decide to fund them or not. In some other countries, once a scientist reaches a certain stature, they may just be granted funds, and it is assumed by that point in their career they can utilize those funds in an appropriate manner. American science is, generally speaking, very competitive by design. Sometimes that is painful, but it is by and large a very competitive process. So if our scientists at the Institute submit a proposal, they are submitting proposals to programs that may have only a success rate of 5, 10, or 20%. So most proposals in that competitive process are not selected. Many of those are selectable, that is, they are very good science, but we are just budget constrained, and only the best of the best get selected.
Which is a country that United States look at for space exploration or scientific studies outside our planet?
I don't know that we look to any nation for leadership and guidance. In fact, I think the world, in terms of space exploration, looks to the United States. That said, space exploration from day one has always been an international enterprise. And I'll give you a very concrete example. When the Apollo 11 astronauts returned with those first lunar samples to Houston, the first chemical analyses were done by Ross Taylor, who is from New Zealand. He happened to be working at the NASA Johnson Space Center, then called the Manned Space Flight Center, but it was recognized from day one the science associated with the Apollo program and the subsequent exploration that we have had of the solar system is always going to be an international endeavor.
I see. In fact, I think that NASA and maybe Lunar and Planetary Institute, the data they have, they are publicly available. Is that correct?
Yes. Yes.
Not only for United States citizens, but for everybody.
Yes. All of our data, after there's initial processing so that it can be readable and so on and so forth to everybody, it is put on what is called a planetary data system. And any credible scientist with the knowledge to access that has free rein to access that, and they can conduct their own independent studies, or they can work collaboratively with American scientists. I know my own team. I run or lead the Center for Lunar Science and Exploration. The work in that center done within the United States is supported by NASA, but that team is truly an international team. I have collaborators in India, in Japan, in Australia, in Germany, in Italy, in Canada, and I'm probably forgetting a couple of countries, and we all work together to resolve scientific issues and advance our understanding of the solar system.
What are the cons and the pros of allowing everybody to look at the data, including probably countries or institutes that you are competing against, including maybe commercial enterprises that they are enterprises or corporations for profit? What are the cons and the pros?
Remember that the way in which NASA missions is supported is through federal funding. That is, the people of the United States is supporting the cost of that activity, and therefore it is reasoned that the product of those investigations should be available to the public, and there is no distinct definition between one part of the public or another part of the public. It is available to the public, and so I think I guess that's the best way to answer that question.
What about for foreign countries that they don't contribute to the NASA budget?
The data is still available. It's space exploration is not something that you should or we have ever done selfishly. It is a human endeavor, and we were speaking before we went on air about those famous words that Neil Armstrong uttered as he put the first step on the lunar surface. And he said, briefly, I'm paraphrasing, but we do this for all mankind. And that has, in fact, been the motivation behind America's space exploration program. I think the United States is richer for it. I think the world is richer for it.
Yeah, my questions, they're looking at the second part of the motto in the Lunar and Planetary Institute logo, exploration.
Mm-hmm.
Because I would like to know what is the status of the art of the space exploration. And I know that in United States we have commercial enterprises that they have that they are active in this field. So would you like to comment on that?
Well, I guess I would first start off by saying that the Apollo program and everything that has followed has always involved commercial companies. NASA engineers are not building every part of all spacecraft. They simply aren't. There always have been commercial partners. One may define the level of partnership or the way in which it is implemented, but NASA has always moved forward with commercial partners, industry, as we say quite often. Since day one. I suspect that, and more recently, I guess I should say, it's realized that the nature of commercial activities can change. That is, it can improve, it can grow. There are certain things that NASA is very gifted at doing, and that is really pioneering, doing the hard things first, paving the way. And once those types of products or processes or activities have been demonstrated, then it is reasonable for commercial companies to step in and repeat those types of processes. So, in the case of the International Space Station today, in the past, NASA flew all the flights with its space agency partners to build, assemble the International Space Station. We now are in an era of where the astronauts are working in this completed facility, and we need to deliver supplies to the crew at that facility. Well, that's a repetitive process. That is something that is not a pioneering process. It is something that a commercial entity can and should step in to start supplying. So that's where we are in today's space exploration business. So while the commercial industry right now may be able to deliver quite routinely and reliably cargo from the Earth's surface to the International Space Station, NASA is, I hope, going to be pioneering a long-term exploration program of the lunar surface.
Okay, let's talk about the exploration. What is the status of the art of space exploration? Where are we going next? We are listening and reading in the news a lot about Mars.
Yes, so there are two different types of exploration, very broadly speaking, that NASA conducts. One is robotic exploration. This is with a spacecraft without any crew. They are controlled from Earth, and they have the capability to explore all parts of the solar system. And we have spacecraft far beyond the orbit of Jupiter. We will have, at times, multiple spacecraft in the vicinity of Mars. We currently have a spacecraft orbiting the Moon. So there is a suite of robotic spacecraft that we use to explore the entire solar system. We also have a human exploration program, and this is a very exciting program. Humans, well-trained humans, can do things that robotic assets can simply not do. And the PI, the principal investigator of the two Mars rovers, Mars exploration rovers, MERs, once commented that everything that they had done in 6 years, a geologist could do in a single day. And that was a very telling comment. There is a person who had invested his career in robotic spacecraft exploration, but still you understood the value of a well-trained human.
Wow, I can't believe it. Everything that was done in 6 years by a robot could have been done in 1 day by a geologist.
Yeah. And it's true. I mean, if you work with geologists in the field, it is absolutely extraordinary the way they can observe. They're very powerful observers, make deductions, and design a survey program, whether it be in situ measurements, sample collection, that greatly advances very quickly the field. In the case of the moon, Apollo also taught us that one of the best ways to advance science is actually bring samples home. And so while you always are interested in making in situ analyses, the golden egg, if you will, is going to be that sample or that collection of samples that you bring back to Earth, where you can then examine them with all of the analytical skill and power that terrestrial laboratories can bring to any problem.
David, you talk about geologists in third person. Aren't you a geologist?
I am a geologist.
Oh, okay. Woof. I was thinking, oh my gosh, maybe he's not a geologist. David, what about the role of geology, the discipline of geology within the Lunar and Planetary Institute? What is that role?
Well, it's a central role, and the underlying reason for that is any planetary surface is a geologic domain. So if you are going to interpret, analyze, collect data from that planetary surface, inherently there is a geologic component. That was certainly true with during Apollo, where astronauts were having to walk over an impact-cratered surface. In fact, I love to remind people that it's terribly important for astronauts to understand impact cratering processes, because they cannot take a single step on the moon without stepping into or onto an impact crater. They are there at all scales. You just have to understand the processes that are involved. There's also volcanic terrains on the lunar surface, but they are far more limited than the impact crater terrains, which are globally distributed. They basically dominate the geology of the lunar surface. So from day one, from the human exploration program on a distant world, the moon, geology has been inherently important.
What are the other disciplines that are important in the Lunar and Planetary Institute?
Most of the disciplines at the Institute are flavors of geology. So we will have field geologists. We will have petrologists, that study minerals and the chemistry of rocks. We will have geochemists. We will have isotopic geochemists. We will have atmospheric scientists to study the envelopes that surround some of the planetary surfaces, although not the moon, but for example, Mars. We will have scientists who understand asteroids and their evolution in space, the potential hazards that they pose for planetary surfaces like the Earth. We will have geophysicists that can use remote sensing techniques at the surface or in orbit to deduce the interior properties of a planetary body. And we of course have image analysis, people who are very gifted at looking at spacecraft images of the planetary surface, whether it be as the spacecraft flew by the planetary body or as it orbited the planetary body, and do what we call photogeologic analysis of those planetary surfaces and the processes that produce them.
You mentioned field geologists. Tell me more about field geologists related to the moon.
Okay, yes. So we've actually seen an evolution in planetary sciences that has served us well, but now may pose a problem. And so now that I've set that hook,
Yes.
let me walk you through this story. So we were extraordinarily lucky to have, first of all, a geologist, Harrison Jack Schmitt, Apollo 17, fly to the moon, walk on the lunar surface, and make some very smart decisions about the samples to return to Earth. We were also very fortunate in that at that time, there wasn't really a planetary science community. Okay, Apollo really created the field of planetary science. So at that time, NASA had to go to the geologic community, and the geologists in the nation and their international partners stood themselves up and created a series of scientific investigations for the lunar surface. They were, by the nature of their field, by the nature of their expertise, almost entirely field geologists. They had all had some field geologic training. Today, we have a planetary science discipline that involves people who may be very gifted at image analysis, very gifted at manipulating large data sets from distant worlds, but may have never done any field geology. And the reason for that evolution is clear. It was required. It was needed if we were going to explore the solar system with robotic methods. But it is also means that the talents utilized successfully during Apollo no longer exist, or exist in a very small segment of the community. And so one of the challenges that we as a field will have moving forward is to train a workforce with that suitable field expertise to work with astronauts when we get them back to the surface.
Do you have the power to steer the education of the universities in order to let them understand that field geology is still important?
We do not have the capacity to steer universities, and it is unfortunate that many universities have been dropping their field geology requirements in their programs. Field geology is an expensive endeavor. There are some outstanding field training programs in the United States. Indiana University in the Midwest is very famous for its program that it runs in southwestern Montana, but there are others. What we can do at the Lunar and Planetary Institute is run short duration training programs, and we've been very successful at that. I think in the last 10 years, I've trained on the order of 200 graduate students in field-based settings, that being Meteor Crater in northern Arizona, the Sudbury Impact Basin in Ontario, and a couple of different volcanic fields in North America. And so each year, we try to take another group and expand their horizons and provide them the tools they will need to help us explore the lunar surface in greater detail.
I fully agree on this problem that we have about the lack of experience in the field for the new generation of geologists. I don't agree that much on the fact that it's an expensive activity if we put it in relationship with having a lab, running analysis, because if you look at the universities, let's say in poor countries, the only thing they have is the field geology. Maybe we may say that safety may be an issue, insurances and all of those things, but going to the field is just the time and the fuel of the car, right? What do you think about that?
I have not run a university-based program for an entire department, so I guess I would withhold additional comment because I just simply don't have the data to comment knowledgeably.
I see. So if you had, now that we are talking about students, if you had to give some suggestion for the students that maybe they want to come and work at the Lunar and Planetary Institute, which would be your suggestion on which kind of career path they should focus?
That's a good question, and the answer has evolved. So, and it's probably worthwhile taking a moment to actually explain how that has evolved. A moment ago, I explained that during the Apollo program, planetary science didn't yet exist or was being born at that time. And so when I, as a young person, watched Neil Armstrong and Buzz Aldrin step onto the lunar surface in 1969, I knew immediately that's what I wanted to do.
How old were you?
It doesn't matter. But you mentioned this word. You mentioned this word inspired, and so they truly inspired me. Well, at that time, there was no such thing as a planetary geology program or a planetary science program, and so what I did was I studied both geology and astrophysics. And so between those two disciplines, I hoped I would have the tools needed to address planetary exploration. And I've been very fortunate. That was a very good decision, and the education I received through those two types of programs has served me well. Now there are planetary science programs, but they are usually at the graduate student level. I was at the University of Arizona for about 16 or 17 years before I came to the Lunar and Planetary Institute, and we did have a PhD program. So we had graduate students, but we did not have an undergraduate program. It was the faculty's sense that undergraduate students needed to specialize in geology, in astronomy, in physics, in chemistry, or some basic science like that before they started graduate studies in the field of planetary science. And that seems to have produced some wonderful talent over the years that I was there. So I think that that was a judgment that has, again, served the community well, and the students going through those programs equally well.
So let's move to the third element of the motto of the Lunar and Planetary Institute: inspiration and exploration since 1968. So it's almost more than 50 years. So you want to talk about 1968-2018?
Yes. So we just celebrated our 50th anniversary, and we're very proud of that. This year, NASA, the United States, and the rest of the world is going to celebrate another 50th anniversary, and that is something I've mentioned previously, the landing of the Apollo 11 astronauts on the lunar surface and their safe return to Earth. It is wonderful to celebrate the success of the Apollo program, wonderful to applaud not only their accomplishment, but the impact those accomplishments had on American society and the entire world. What they did permeated the fabric of the United States in a way that nothing that I can think of has ever done before. That said, I want to be careful that we don't spend too much time looking backward. I think it is absolutely essential that we look forward to a new era of science and exploration on the lunar surface. What the astronauts did was amazing, incredible, just awe-inspiring. But they explored an incredibly tiny portion of the lunar surface. I mean, literally, they spent hours, only hours, on the lunar surface. We have never been to the North Pole region of the moon. We've never been to the South Pole region of the moon. We've never been to the far side. Only one country has yet landed on the far side, and that was China just a few weeks ago. So the bulk of the moon lies entirely unexplored. And it's a magnificent destination. It is only 3 days away, so it is relatively easy to get to. It is relatively easy to return from. We should be able to bring back hundreds of kilograms of rock for terrestrial laboratories to analyze. It is, I have argued, the single best place in the solar system to understand the origins of our solar system and the evolution of that solar system. The record there is better preserved than anywhere else. You might want to go to Venus at some point in time. You might want to go to Mercury at some point in time. You might want to go to Mars at some point in time. But in all of those cases, the record is not going to be as exquisitely preserved as it is on the moon.
It's fascinating. I'm thinking about how could I do to go to the moon? Who's going to the moon and when?
Well, I'm hoping that the United States is. The current administration released Space Policy Directive 1, which directs NASA to return to the lunar surface for long-term exploration and utilization. Okay, so the objective here is not simply to land and come back and be done with it. The idea is to go to the moon and explore it in great detail, to inhabit it for periods of time, to utilize the resources of the moon in a sustainable way. And we now have a program. It's called the Lunar Exploration Program. It does involve commercial assets. You had asked about them earlier. The hope is that commercial companies will launch spacecraft, small robotic spacecraft, to the moon with a cadence of about once per year. NASA itself is designing a mid-weight capacity robotic lunar lander that will hopefully be deployed in the 2024-2025, and we hope to have crew on the lunar surface by about 2030. We've done global lunar landing site studies, so we know where we want these spacecraft to go. We have design reference missions for the first 5 landings of astronauts on the lunar surface. So we have already walked quite a ways down the path of designing the architecture that we hope will be built and flown in the next decade or so.
What are the resources that we could find in the moon? Which kind of resources are you talking about?
Okay. Well, first of all, I'm going to just pause a moment and say, of course, the most important resource as a scientist is knowledge. The knowledge that we are going to retrieve from the lunar surface is something that we cannot glean here from Earth. It's not something that we can just imagine by sitting at home. It is the type of knowledgeable resource that only can be recovered if we go there and we bring it back. Okay? But I think, if I understood the question right, you are thinking as a petroleum geologist. You're thinking of resources that can feed a sustainable exploration program. And at the moment, the resource that has captured most of the attention in the field is volatiles. And volatiles include carbon, include nitrogen, but most importantly include hydrogen and oxygen. These are 2 elements that provide the consumables that a crew would need, breathing, for example, drinking water if they need it, but it's also the 2 elements that are very important for producing rocket fuel. And so we hope that we can recover significant quantities of volatiles on the lunar surface. And this is a bit of a game changer. in the days of Apollo 11, 12, 14, 15, 16, and 17, my advisor and the original Apollo principal investigator scientist described the moon as being rather dry. And it is relative to the Earth. You don't see any oceans on the surface. There are no rivers flowing across the landscape. And one of the reasons they said that is the rocks have, at that time, no detectable water in them. But this underscores the beauty of sample return missions. Many years later, our analytical techniques on this planet improved, and so we could go back into the lunar sample collection, the Apollo collection, and reanalyze them, and we were finally able, as a community, to detect small amounts of water. We also have made, as a community, detections of hydrogen from orbit, and it is now postulated that we have icy deposits in the polar regions that could be recovered for the purposes that I described earlier. So one of the goals over the next decade is to determine if those volatile deposits are really there, what their distribution is, what the concentrations of the volatiles are, and begin testing methods for extracting them. And this is not simply an objective of NASA and the American space agents, scientists and exploration community. This is a globally recognized attribute of the moon. Russia, in coordination with the European Space Agency, is designing missions to do similar types of studies, as are other space agencies around the world. So a lot of the path forward is going to be steered by the exploration efforts to determine the availability of that particular resource.
And when you were mentioning resources, you also mentioned to recover them in a sustainable way. What is the concept of sustainability in this context?
That is still, I think, to be determined. Initially, we envision astronauts going down to the lunar surface for a period up to, say, 42 days per year, and to repeat that on an annual cycle. That would be very good. We're not yet talking about inhabiting the lunar surface, although one can see that on the horizon as being an interesting thing to do. And that's the perspective that we have here in the United States. Our colleagues in Europe have a different vision. The European Space Agency really are interested in inhabiting the lunar surface. They talk about a moon village where people would be sustained over the course of an entire year. And so each country or each space agency is defining those objectives differently, and the time scale over which they'll be implemented differently. But I think there is a growing sense that the moon really does represent an important part of our future.
Which is the most exciting idea that you follow among all of these ones that you were talking about? What is the one that excites you the most?
Well, I don't know that you can ever narrow it down to a single point. But I have said that we've done a global lunar landing site study, and by that, it was a 6-year study, mind you, a very, very detailed study. We tried to identify everywhere on the lunar surface where we could address this nation's highest science objectives for exploring the moon. And after that 6-year study, we determined that the highest priority landing site is the Schrödinger Basin on the lunar far side within the South Pole Basin. we can do more science in that one location than anywhere else. And so I would like to see us pioneer landing on the far side, have a sample recovery program from that terrain, bring those samples back to Earth, and I think that we will make immense progress in our exploration of the lunar surface. But that, in my mind, that is a human-assisted robotic mission. That, in my mind, is a first step towards human exploration. As I said earlier, human beings, well-trained astronauts, can do absolutely amazing things when they are put in a terrain like the lunar surface. If you really want to, inspire people, as you spoke about earlier, and advance the science in dramatic ways, you want to get crew back on the lunar surface. And so there currently is a design reference mission where we have 5 landing sites for crew. The first crew of 4 would land at Malapert Massif, which is in the South Polar region on the near side. The second crew would land at the South Pole. The third crew would land in the Schrödinger Basin, which I've already described. The fourth crew would land in Otaniani Crater on the far side. And the fifth crew would land in the middle of the South Polacan Basin, which I mentioned a moment ago is immense. By immense, I mean it's 2,500 kilometers in diameter. It's continental in scale. It is a dramatic basin and would just be fun to explore.
Fantastic. Why the Lunar and Planetary Institute stops at the edge of the solar system? Why was just the Lunar Institute or focused on the moon, then it focused on the solar system? Why does it stop there, and where is that edge?
Yes, there really isn't an edge. So let me just kind of repeat what you said for your listeners. So it is true that our institute began, as I said, with President Johnson's remarks, as the Lunar Science Institute. Once Apollo was complete, we were asked to expand our portfolio to the entire solar system, and so we were renamed the Lunar and Planetary Institute. But we are, as a scientific organization, interested in the processes of planetary formation, of planetary evolution. And so while we may at times be focused on the moon or Mars or a moon of Jupiter to kind of tease out the details of these important processes, our minds are wide open to the type of input that we can get from other stellar systems, other extrasolar planetary systems. So in fact, just last October, I convened a meeting about planetary bombardment, and during the first billion years of a stellar planetary system, we held the meeting in Flagstaff, and I made sure that we had one of the leading speakers who uses the Spitzer Space Telescope to look at debris disks that are forming around other stars, because the processes that produce those debris disks around other stars, which they can see telescopically, are very similar to the same processes that help shape our solar system. And so while at times it may appear that our work is actually constrained to the dimensions of our solar system, intellectually that is not true. Intellectually, we have no boundaries.
I see. In fact, sometimes the boundaries are just arbitrary definitions of concepts that have to be put down for protocols or
that's true. We try in planetary sciences not to be constrained by narrowly defined disciplines, as may have been traditional, say, 50 years ago or 100 years ago. We understand that planetary exploration is an interdisciplinary, a multidisciplinary process. And for example, although I have spoke hopefully convincingly for the need for lunar science and exploration, the moon is not the only planet I study. I study the bombardment of Earth. I study volcanic processes on Earth. I study volcanic processes on Mars. Nobody, myself included, is constrained to a single planetary body. We are more interested in the processes writ large that shape the evolution of stellar systems and more importantly, planetary systems.
David, you've been several times giving talks and in TV and the radio. Do you want to talk about some curiosities about the moon? Maybe, society at large, when you're talking with them and for the outreach, they ask you maybe one of those silly questions about, the things related to the moon.
Yeah, so I guess I would start by saying the following. While it is always true that we go to places like the moon or elsewhere to understand the processes that shape that body, we are really trying to better understand our own planet Earth. Okay? And that is especially true in the case of the moon. The moon is Earth's moon. It is our neighbor. It is that object that, as you said at the top of the show, you can see from your backyard every single day, unless it's cloudy here in Houston. And it is a remnant of the original processes that formed our planet. So if you want to understand the origin and the early evolution of the Earth, the best place to go is the moon. For example, the Apollo astronauts brought back a lot of samples that were produced by impact events on the lunar surface, from impact craters on the lunar surface. Those samples came back to Earth. We determined that there was an intense period of bombardment during the first billion years of solar system history, and that completely shaped the surface of the Earth. In fact, geologists, my colleagues, are still wrestling with the magnitude of that onslaught and the implications of that onslaught. It is one of these things that is almost incomprehensible, the way it would have shaped the Earth's surface. And intriguingly, this bombardment seems to intersect in time when life on our planet originated. And so it has always begged the question since Apollo whether that bombardment had something to do with the origin and early evolution of life on our planet. And again, those are questions that's just very, very difficult to address here on Earth, but they are the questions that can be answered, I think, rather eloquently on the lunar surface. And that just reminds me, just 2 weeks ago, we published a very exciting paper where we described a small rock fragment in an Apollo 14 sample that we think came from the Hadean Earth. We think it is a rock that formed 20 kilometers beneath the Earth's surface nearly 4.1 billion years ago, and in one of these massive impact events was excavated from the Earth's crust, launched into space, where it landed on the lunar surface, waiting for 4 billion years until Apollo 14 astronauts picked it up and recovered it and returned it to Earth for us to study. So this particular sample is providing us immediately insights into an epoch of Earth that has remained very, very murky, despite a lot of work by some brilliant geologists here on our home planet.
Thank you so much, David Kring, senior scientist at the Lunar and Planetary Institute. David, do you want to shout out to anybody? Do you want to add anything else that you didn't have the chance to say yet?
No, other than to say thank you very much for this opportunity, and I hope that we were able to meet that first objective of our institute and inspire a few people this evening.
All right. Thank you so much to you listeners. This is Mini Geology radio show. You can follow us at minigeology.com. You can write me at minigeology@gmail.com. Thank you very much to everybody, and thank you to you, David.
I'm gonna leave Houston in the morning, man, in the morning soon. I'm gonna leave Houston in the morning, man, in the morning soon. 'Cause the building may be burning by tomorrow afternoon. I don't want to be nowhere around. Going back to the country, way back where I was born. I'll be going back to the country, way back where I was born. Everybody got along together without burning the buildings down.